Hello. Okay. So we can get started. Hello, everyone. My name is Khurram Malik. I am a Director of Product Marketing for CXL Product Portfolio here at Marvel. So let's get started. So you might have heard and seen our big product announcements at FMS, and I'm here to talk a little bit more about it, what we are doing, what the product looks like, and why actually we are building this product, right? So first of all, what we have seen, the number of compute core counts has been growing up significantly, but the memory bandwidth per core has been going down. And recently, what we have started to notice that the gap is continue to increase over time, that CPUs are becoming more and more inefficient for memory-centric applications. The second thing what we have started to notice that what does it take to get to a more memory pins connected to the CPU, and there is a constraint on the packet size as well as on the thermals, and there are certain limitations which cannot let these CPUs to have much more memory as it required for the memory centric application. Also, what we have started to note is that the second most expensive component spent on the data center is happen to be a memory, right? And Meta has published a paper which openly said that half of the platform cost is spent on memory. Just think about it, half of the platform cost, right? And one of the most challenging part which these hyperscalers and customers would like to anticipate is how we can recoup those costs. What does it require? We can monetize those costs for a much longer period of time, right? And that's where sustainability, recycling DDR4, recycling or decommission DDR4 comes into play, and how does that overall bigger picture comes into play, and what can be done to leverage that, and what CXL product portfolio needs to be offered to obtain that. So these are the three use cases has been very well defined, and you have been hearing probably since many years. The first one is a memory expander. It simply adds memory capacity and memory performance to the CPU. And it enables the flexibility. When we talk about flexibility, means it enables our customers to mix and match different types of DRAM sitting inside the enclosure. For example, CPU which can only support DDR5 will be directly attached to the memory, but with CXL controllers sitting inside the appliance will have a DDR4 connected to it to provide a more memory capacity. And then we have also some customers would like to use DDR5 for memory expansion if they have application required for higher memory bandwidth. It depends upon what application you're looking for, what pain point you are trying to address. The middle one has been talked a lot as well. The memory pooling, what does it do? It enables multi-dynamic memory allocation where multiple hosts can access to same memory and take advantage of it. A lot has been talked about on that angle, but there are many POCs has been happening, but still yet to see what application and what TCO will take that use case and go into the mass production. On the very right side, what I'm sharing here is a memory accelerator. And this is a very interesting use case. What has been happening here is industry has seen great benefit of bringing accelerator closer to the storage for SR-IOV virtualization. But also there has been discussed that how we can bring accelerator closer to the memory. When we talk about accelerator, means how we can bring the compute capability closer to the memory so that the data get processed on the card sitting right next to the memory, and then shove the data back to the processed data to the host. So with that said, what we have done, our thorough analysis, and we have constructed, there are two main pain points what we like to address, and that what shows here. The x-axis is the capacity, the y-axis is the bandwidth per core. What we have seen after talking to many customers evaluating thoroughly on the application side of view, one use case which shows on the very top left side is higher memory bandwidth per core, right? And this is what I mentioned that that's where one of the biggest challenge industry has been facing. And how we're going to address that is because one of the common question could be asked, okay, what ratio is the best one, right? Again, it depends upon the different workloads, but when we navigate through and say what application can be target is what we anticipated to see 10 gigabytes per second per core is a rough estimate where industry has started to realize that that could be a good starting point to go with, right? And the second is a higher capacity. And higher capacity is like how much capacity I need for my application that needs to be resides inside the server, right? And the capacity we have seen from roughly from 3 terabytes to 6 to 8 terabytes. And now we are talking about capacity. In storage world, yes, 3 to 4 terabyte is nothing, but we are talking about capacity, and most expensive memory capacity is on the sitting inside the server. So in order to address these two core pain points, Marvell has developed a product portfolio with a product brand name called Structera. Uh, One of the common questions asked by me, okay, why Structera and what does Structera means? So just a quick definition, Structera means structured of new era. CXL product portfolio defines how to develop the chip with the new structural definition of the product. So we have addressed those two pain points using Structera A and Structera X. Structera A focused on near memory accelerator, and Structera X focused on memory expansion controller. So what we are trying, what we are offering using Structera A is a PCI Gen 5 by PCI Gen 5 1 by 16 lanes and CXL 2.0. And the memory capacity, which memory bandwidth is a critical one, which I highlighted here, is 200 gigabytes. And when we talk about 200 gigabyte is the capacity between the memory and to the controller, right? And earlier I mentioned that industry would like to bring compute capabilities closer to the memory. So we have 16 new V2 core embedded inside the controller. And the purpose of these V2 cores are customers can run some of the application to get refined data on top of it. We also support inline LZ4 compression algorithm. And the purpose of that one is if for certain application, for certain workload, for different customers, they would like to have the compressed data and would like to utilize more memory based off of different workloads, they can utilize that. And of course, this is built off a 5 nanometer processor node, means the power consumptions are the most critical, one of the critical part, where we have heard since morning how critical the power is for these chips. And that's where the power consumption is less than 100 watt, right? And if you think about it, what we are trying to address is how to provide higher memory bandwidth per core sitting inside the card closer to the memory for all the data needs to be processed in this controller, and refined data goes back to the host from that card. That's what the critical pain point what we are trying to address with this product. One of the common question asked, okay, which application can take advantage of it, and what do we have so far? So if we think about it, deep learning recommendation engine model is one of the application which can be utilized for this particular application. And just a quick update, deep learning recommendation engine is all we have used that. What happen is when we can go to any media and we can click on one short video or one video, they, they can understand what information we are looking at, and they can recommend all the other videos. That is a part of deep learning recommendation engines models. And what we are trying to show here in a standard in a standard deployment, you will have a backplane connected to compute fabric switch. Then you have XPUs, it could be CPU, XPU, GPU, and connected to the CPU, which has a smart NIC connected for the outside the box, and then it has its own memory attached DIMMs connected to it. The important part which I'm trying to show here is, if we think about it, a server which has a 64 cores, right, and which gives 400 gigabyte memory bandwidth, and consumes around 400 watt of power, right? If you think, if you do a roughly a math, it turns out to be it's giving you 6.25 gigabytes per second and translate into a 1 watt per GPU. This is how it is used without any of the components. Okay, what we are trying to address with the product is, now we have one card memory accelerator. As I mentioned, it has 16 cores. Now, the total of cores, 16 plus 64 is 80 cores, and added up to a 600 gigabyte DRAM bandwidth and consumes 500 watt, which translates into a 25% higher cores and around 50% higher memory bandwidth added into the server. This is another application where we want more bandwidth per core. What do we need to do? We can add another card. And these cards are like an add-in card form factor type of a card with CXL support, right? So now in this case, what we are showing here is it has 96 cores. The server has sitting on a 96 cores with 800 gigabyte of DRAM bandwidth. Roughly, it increases the 50% cores and doubling the memory bandwidth where it was. And which applications can take advantage? This is one application. The second application could be graph analytics, sparse database, and vector database. Are few are the applications where has been very much focused on to do a lot of work which can take advantage of these ones to provide higher memory bandwidth per core to address this challenge. Okay, next one, I am jumping into memory expansion. As I mentioned, one of the main pain point we have been hearing over and over, that how we can have better control on our capex, and how we can use how we can have better utilization of the memory which has been used on a previous generation CPU, and how we can enable those to the next one. So that's where the CXL is going to enable that, and that's where we have a product called Structera X 2404. It's again PCI Gen 5.0 CXL 2.0 support. This product enabled 3 DIMMs per channel, a total of 12 DIMMs sitting behind the controller, and these are DDR4 DIMMs. The capacity of, you can think of it on a single card with 12 DIMMs and 512 gigabyte of a DIMM, you can get 6 terabyte of DRAM capacity from this card. One of the important factor here is we have seen and heard that how critical it is to use DIMMs to get the higher capacity behind the CXL, right? And this is where it's going to solve the problem. This product also support LZ4 inline compression algorithm, right? And when we talk about CXL and when we talk about compression algorithm, always the question comes into play that what benefit will bring and what does it require to enable this compression algorithm, right? And in a memory world, when we all know, we talk about cold pages and hot pages, and all the hot pages industry would prefer to move those to the main memory and the cold pages to the CXL. Or it could be a possibility that within the CXL card, you can have different tiers of memory. You can have hot pages, cold pages, and then move those pages accordingly as based off your requirements are. Google, it's a public information, has has published a great data that the cold pages can be compressed at 3x the capacity, 3x the ratio, right? And when you have mixture of cold pages and hot pages, the best algorithm uh, and most optimization method you can get at least minimum the 2x the ratio. So that's where the value prop comes into play. That and Meta has public paper. Um, it's a public, also open paper that uh, in a rack, half of the memory is untouched in a rack for 2 minutes. Think about it. Half of the memory is untouched in a rack for 2 minutes. What does that mean? It translates that these memories does not need high bandwidth all the time. These memories, you don't need to have very high bandwidth memory all the time. If for 2 minutes half of the memory is sitting idle, this means the user can immediately know which applications are taking more memory or require higher memory bandwidth, and can work and separate those memories from the one which does not require more memory, and then use that memory to compress to get even a higher memory capacity. So with that said, we have seen a lot has been talked about recertified DDR4 and reused DDR4, and this is one of the key application can be used where you need more capacity to utilize for your applications to provide the required capacity. And how this just displaying here quickly, you have a CPUs connected to you over CXL, PCI bus, and with PCI bus you have a card connected with the 12 DIMMs. A total of, and how you get to 12 DIMMs is a DDR4, 4-channel controller with 3 DIMMs per channel gives a total of 12 DIMMs, right? And in fact, industry would like to see how you can get even better, more and more of those. Sorry. Okay, there is another application. Not there, even though which I mentioned previously, reuse of DDR4 for memory expansion is a one case, but there are other applications where industry would like to use DDR5 for memory expansion, and we have a product called Structera X2504. Again, it's a 4-channel controller, 2 DIMMs per channel, total of 8 DIMMs connected to a single controller. It also supports LZ4 compression algorithm, as well as built off of a 5 nanometer processor node. Gives a total of 4 terabyte capacity for a single memory card. So this is on the nutshell what we are trying to address in this one is 2 use cases, and each use cases we have memory accelerator and memory expansion. With memory expansion we have DDR4, DDR5. With memory accelerator, focus is on DDR5 to give you the higher memory bandwidth per core to address some of the pain points of how to balance the bandwidth per core within the server. 4-channel of DDR, PCI Gen 5.0 and CXL 2.0 support. Key takeaway, I will say, okay, if you have more questions, please come and see us on the booth, talk to me, and we are pioneering and leading in this segment based off of 3 DIMMs per channel controller, based off of memory accelerators, as well as providing 2 DIMMs channel controller with total of 8 DIMMs for DDR5 enablement. A lot has been, there's a great momentum. I think industry at this point has been looked up what is required and what does it needs to take into the mass production of a deployment rather than what can be done. So with that said, if you have any questions or
I'm sorry, Karma,
okay.
we're going to have to move forward without any questions, but thank you very much for your presentation.